A little bit of electrostatics practice is what we're going to try to do today. And we're starting off with a little triangle of charges. So each of these are 11 microcoulombs. So this is a millionth of a coulomb each. And they're separated by 15 centimeters. And the question is, what is the net force on any of the charges? So turn to the person beside you and just in one or two sentences say how you would do this. Not the numbers, but just how would you do it?
Oh, I see.
After you get the two forces, use the top one. I recommend
Oh wait, they're repulsive.
like ultimately those two.
I did this question. Wait. Yeah, they're
Okay,
repulsive.
pause there.
Yeah, they're repulsive. They don't.
Sounded like some good thinkings.
No, you're not.
I heard Jake say it's repulsive. These are all three the same charges, so there's going to be repulsive. Let's focus in on just the top charge. It's going to be repelled in two directions, right? So it's going to be pushed this way by the bottom right charge, and it's going to be pushed the other way straight out by the bottom left charge. Yeah?
Isn't it a vector?
Yes, it's a vector. So it's not, yeah, so Luke, which direction is it going to end up going? It's going to end up going straight up, right? So we can componentize these two. Good. And as Jeffrey says, the horizontal components are going to add to 0, and we're just going to end up with this sort of Fy component, right? If we call this one F. And so if we get the Fy, we can just double it, and that'll be our net force. So let's go back and put your hand up if you remember Coulomb's law. Okay, that's electric force. Put your hand up if you remember electric force formula. Put your hand if you remember gravitational force formula. What's the gravity one?
G pose.
Good, GMM over R squared. So electric force, I'll say Fe is KQQ over R squared. We can find that out. We know one of the angles in this little triangle, right? Which angle do we know? 60. Yeah, this is going to be 60 because this is an equilateral triangle. So we can say that Fy then, well, what would you tell me? What is it? It's going to be this kind of green colored force times what?
Sine 60.
Good. Times the sine of 60 degrees. So if we find this out, we can just multiply by the sine of 60, and then we're going to have to double it, and then that will be our net force. So take a minute and try to calculate that. The charges are the same, so you can just square them. Mm-hmm.
Can you do one where it's like one is not, it's not all the multiple charges, and one is like.
Oh, I got other things to do here.
That just seems like hell.
So the force here, this F, I believe, is about 48 or so.
I got 48.3.
Perfect. And then we have to multiply by the sine of 60, and that comes out to somewhere around 42, I believe. Which, by coincidence, is the answer to the meaning of life and everything. But we have to times that by 2, right?
Yeah.
So the net force on any of those 3 charges should be about 84. Now, just to be clear, come on, you can do it. It's very confused today. If we held the 2 bottom charges in place and you released the top one, could you use this force to find out like a speed that it would be some distance further up?
No, because it changes.
Say that again, Jake?
Because the force changes as it moves.
The force will change as it moves. So you always want to keep in mind, this is the trouble with studying gravity in grade 11, right? Because gravity doesn't appreciably change when you go, you know, like 3 meters off the earth. It's just the same force, right? But if we increase this distance from those 2 charges, it's going to change quadratically, right? So it's going to change a lot as you move. What could we use that would be a little easier? Yeah, you can use the energy if you can. Okay, good. Let's draw a line under that one. Okay, now having done that, hold your hand at eye level, right here. Right here is like, I'm fine. And here is like, I've had it up to here with this. No, this is like, yeah, this is easy. We can move on, there's no problem. And down here is like, I'm lost, I need more of this. Okay, show me in 3, 2, 1. Okay, good. I should probably make you close your eyes when you do that. But. Okay, let's go on to a next thing. I just kind of wanted to see how you were feeling about this. This is one that was not in your assignment. Let's take a positive charge, and actually I'll draw that red. So this is a positive charge, and let's say it's 5.7 microcoulombs. And then let's say this is 25 centimeters away. You have a negative charge. And let's say that's 3.5 microcoulombs. And let's call this, we'll call this Q1 and this is Q2. And the question is, where could you place a charge? So I'll write the question over here. So where could you place a third charge? That would have a net force of 0.
What is the charge as opposed to me?
Think about it, talk about it, take a couple minutes.
Does this mean it would have to be the same, right?
I'm gonna make this part 1.